students. I hope you are all fine. Okay. Today's session we are going to see a new chapter, that is electrochemistry. Okay. Electrochemistry, this exam point of view, very important, because the weightage mark for this chapter is 5 marks. Okay. Right. Electrochemistry. Do you have any idea for that? Electrical energy. So in our day-to-day life, without electricity, we cannot imagine our life. Okay. So electrical energy we are getting from many sources. Thermal power stations, our neighbor Tirunelveli thermal power stations, and Kudangulam atomic power stations. So many ways we are getting electrical energy. Okay. So today's session also we are going to see how the electrical energy we are getting, that what is the scope. Okay. So and some numericals, nernst equations, and cells, batteries. So all the concepts we are going to see. Okay. First of all, what is mean by electrochemistry? Okay. Electrochemistry is that branch of chemistry which deals with the study of production of electricity from energy released during spontaneous chemical reactions, and the use of electrical energy to bring about non-spontaneous chemical transformations. Here, redox reactions. Spontaneous reaction means redox reactions. So redox reaction means the reactions takes place both oxidation and reductions simultaneously. That is called redox reactions. Okay. So redox reactions, it carry on its own. Okay. So the chemical energy is converted into electrical energy. The flow of electrons from anode to cathode. Okay. The energy is converted into electrical energy. Okay. So what is the scope? We are going to study this electrochemistry chapter. Okay. First one, production of metals like sodium, magnesium, calcium, and aluminium. Okay. So electroplating. Electroplating means coated of one metal with another metal. Okay. Cheaper to costlier. Okay. That is electroplating. Purification of metals. So finally we are getting the pure metal from that electrolytic refining. Okay. So aluminium and electrolyte zinc, then silver. Okay. Okay. Batteries and cells used in various instruments. Okay. So these are the importance of electrochemistry. Okay. So after that, we are going to see some basic ideas. Okay, before entering into the chapter. Conductors. Conductors means already you studied in your physics. So conductors means substance that allow electric current to pass through them are known as conductors. Okay, the ability to conduct the electricity, that substance we called as conductors. Okay. Metallic conductors are electronic conductors. Substance which allow the electric current to pass through them by movement of electrons are metallic conductors. Example, metals. Copper wire, okay, is a good metallic conductors due to the presence of valence electrons. Okay. So the ability, the metals to conduct the electricity. Okay. Electrolytic conductors or electrolytes. Substance which allow the passage of electricity through their fused state or aqueous solution undergo chemical decompositions are called electrolytic conductors. For example, all the aqueous solution of acid, HCl, H2SO4, okay, and bases like sodium hydroxide, sodium chloride, potassium chloride and salt. Okay, so here ions, the presence of ions in aqueous medium, so that ions to conduct the electricity to one electrode to another electrode. Okay, so electrolytic conductor, the best example sodium chloride in molten state, so the free ions are present easily to conduct the electricity. Okay, right. Electrolytes are two types. What are the electrolytes? Already we studied strong electrolyte. Strong electrolyte means it undergoes 100% dissociations. HCl is a strong electrolyte. H plus Cl minus, and NaOH is a strong electrolyte, Na plus and Cl minus. Okay, so weak electrolyte partially dissociated. So before the lesson we studied I value for greater than for 1, that is dissociation, easily it undergoes dissociate, and I value is less than 1, that greater than 1, less than 1, association. So all the concept we studied. Okay, here also strong electrolyte and weak electrolytes. Okay, so electrochemical cells, after that we are going to study the difference between the electrochemical cell and here, the electrolytic cell. The basic cell. Difference between electrochemical cell and electrolytic cell. Okay, so the electrochemical cell, the best example galvanic cell or Daniel cell. Okay, so definitions: the electrochemical cell, which is a device used to convert chemical energy into electrical energy. Okay, so here electrolytic cell, which is a device used to carry out non-spontaneous chemical reactions by electrical energy. Students, you see here, this electrochemical cell is made up of two half cells. Okay, each half cells, it contains electrodes, two same electrode or different electrodes. The electrodes are dipped in their own corresponding electrolytic solutions. Okay, and also the electrodes are connected through this voltmeter. These two half cells are connected between the salt bridge. Okay, so what is the use for this salt bridge? The salt bridge is used to maintain the neutrality between these two half cells. Okay, so here the anode, the electrons, movement of electrons, it can be started from anode to cathode. Okay, anode to cathode, at the time what's happening, the electrons, it's the loss of electrons takes place by anodic half cell, and gain of electron takes place by cathodic cell. At the time the energy created. So electrochemical cell is the energy conversion of chemical energy into electrical energy. Okay, so that is electrochemical cell. Okay, this is a spontaneous cell because of its carry on its own. Okay, that is, it is a spontaneity reactions. Okay, you see here, this is a electrolytic cell. That electrolytic cell, the electrodes are present in same container. Both electrodes are present in same container. The electrodes are connected through these batteries. We have to apply the extra energy to these batteries. At the time what's happening, the energy, it's entering into this electrode, heat energy is produced. So that time the presence of electrolyte, that dissociated into their ions. Okay, so here the electrical energy is converted into chemical energy. Okay, so you see the basic difference here, the chemical energy is converting into electrical energy. For a normal electrolytic cell, the electrical energy is converting into the chemical energy. Okay, so here the difference is anode is positive, cathode is negative, because the electrons entering into the cathode and deposited in the anode. Okay, so electrons entering to cathode and leave by the anode. Cell reaction is non-spontaneous because external source we are applying. Okay, so the overall, that is, it is combination of two half cell containing the same or different electrodes in the same or different electrolytes. Anode is negative, cathode is positive. Here single cell containing same electrodes present in the same electrolytic solutions. Anode is positive, cathode is negative. Here the movement of electrons started from anode to cathode. Here the movement of electrons entering to cathode. Okay, and spontaneity, it is a spontaneous reactions, it is a non-spontaneous reactions. For this electrochemical cell, we need salt bridge because maintain the maintain the neutrality for between these two half cells. Here no not required for salt bridge. Okay.